Hello everyone, now we are going to solve the questions based on the whirling of the shaft. A shaft of 50 mm diameter and 1 meter length carries a disc which has a mass eccentricity equal to 190 micron. This is in micron, remember. So the displacement of the shaft at the speed which is 90% of critical speed in micron. So what we have to calculate the displacement of the shaft, that means the deflection of the shaft we can say, because shaft is going to be deflected after a certain time. We have seen in the derivations. Okay, so we all know the formula for deflection of the shaft is, we have calculated, that is y is equal to, this is y is equal to E upon omega n upon omega to the whole square minus 1. This was the formula. Okay, now E is given, eccentricity is given, that is equal to 190 micron. So this is 190 upon omega n by omega is what? See, it is a statement is given that the displacement of the shaft at the speed of, at the speed which is 90% of the critical speed, and we know that critical speed is omega n. So it is saying that omega is equal to 90% of critical speed, that is omega n. That means omega n upon omega will be equal to 1 upon 0.9. Okay, 1 upon 0.9. So you just have to put this value here. That means 1 upon 0.9 to the whole square minus 1. So when you solve this, you will get the value of y, that would comes out to be 810 micron. Since their units are same, so you need not to worry about anything. Whatever be the unit of the eccentricity, that will be the same unit of this. Okay, because this is a ratio. Okay, and the ratio having no units. So this would be the 810. That 810, that means option A would be the correct answer. So this type of questions is not so complicated, but you must have to be careful, because this type of statement can confuse you. So the speed of the critical speed, which is 90% of the critical speed, sometimes will say that the critical speed is 90% of the speed of the shaft. So like that, there may be a variations in the questions. So you just need to learn the formula, and before putting the values here, you just have to go through the values carefully, and you will get the right answer. So this was the solution of that question. I hope you will not get any doubts here. This was the numerical type questions. Okay, we have done the 32 questions on the whirling of the shaft as well as critical speed of the shaft. So thank you.